Welcome to the deep dive. If you ever bought an air purifier, well, this conversation might make you rethink everything you thought you knew about clean air.
Yeah.
Today, we are tearing into sources that basically declare the industry standard, what we all kind of assume is the gold standard for breathing safety, a global mistake.
It's a big claim. We're diving into a real challenge to the status quo here. The core premise we're looking at is, well, it's provocative.
Definitely.
What if the main thing limiting how long we live, our health, maybe even our intelligence,
Right.
what if it isn't our genes or the latest medicine, but these tiny environmental toxins we breathe in constantly?
Hmm.
And these sources, they introduce something called the maze air purification technology. They claim it's the only way to get a 100% toxin-free environment.
And potentially lead us into a new evolutionary era.
Yeah.
That's ambitious.
Very. It sets the stakes incredibly high.
Right. So our mission here is to unpack these claims, impartially. How does this new tech supposedly succeed where everything else fails? And why is it apparently already changing things like semiconductor manufacturing?
That's the plan.
Okay, let's start with the main conflict, the failure of the current standard. If you're like most people listening, you probably rely on a filter using HEPA standards, high-efficiency particulate air. Why do our sources say HEPA just fails completely?
Well, they argue it's a fatal design flaw. It's inherent in any system that uses what they call porous media, basically, a physical barrier with holes.
Like a sieve.
Exactly. And the source material details this core contradiction. To block the really harmful stuff, the ultrafine particles, you'd need pores so incredibly tiny that, well, air just couldn't get through effectively.
Right. If the air can't pass, the machine's pointless.
Precisely. So manufacturers have to compromise.
Yeah.
They make the pores bigger, wide enough for decent airflow.
Okay.
But in doing that, they basically create a perfect highway for the real danger. Particles smaller than PM 0.1.
The ultrafine ones.
Yeah, the ultrafine toxic particles. These are so small, they just sail right through the filter material, settle deep in your lungs, and can even get absorbed into your bloodstream and cells.
Okay, here's the bit that really makes you look sideways at your own filter at home. The sources claim that even top-tier HEPA filters stop doing their job effectively within days of use, not months, days. What makes them fail so fast?
It's the bigger stuff, actually. The PM10s and PM2.5s, visible dust, pollen, things like that.
Right.
They quickly clog up those larger pores that were designed to let air through. The sources describe the result as creating a kind of non-breathable plastic film across the filter surface. Once it's clogged like that, the intended airflow just stops. The filter system is, for all practical purposes, useless.
Okay, wait a second, though. If the filter's totally blocked, wouldn't the machine just stop working? Or the fan motor would strain?
Right.
Why would anyone think it's still purifying air?
That's the really critical part of the failure they describe. Because these filter systems, they rely on seals that are never perfectly airtight, and the machine chassis itself often has tiny gaps.
Right, nothing's perfect.
Exactly. So the air, being air, finds the path of least resistance. It just reroutes around the filter entirely.
Oh, wow.
Through leaks, little gaps, imperfect seals, it bypasses the clogged filter medium. But the fan's still running. It's still blowing air out.
So to the user, it seems like it's working fine.
Yeah, it gives this really dangerous illusion of safety.
That feels like the ultimate deception, especially when they mention filters that look clean after a year or two. I mean, I've definitely done that. Looked at a filter and thought, must not be that dusty in here. Barely caught anything.
And that appearance of cleanliness, it's deeply misleading, according to these sources. It's caused by just simple static electricity, electrostatic adhesion.
Like static cling.
Pretty much. It makes only the larger bits of debris visibly stick to the filter surface. But the real danger, those invisible PM 0.1 particles, they're just blowing straight through or around. This is why, they argue, people vacuum their filters or keep using them for years thinking they're still working.
Yeah.
The authors even point out the absurdity, like, if the filter stays sealed in its original plastic wrap, the machine still blows air, and some users might actually think some purification is happening just because the fan is on.
That's unsettling. And that lack of real filtering leads directly to their most, extreme claim. That HEPA filters don't just not extend lifespan, they actually accelerate death. That's a huge statement.
Right.
What's the mechanism they point to for that?
It's not about immediate poisoning, it's about silent, slow accumulation. Because these PM 0.1 particles are so incredibly tiny, your body's normal defenses, like the cilia in your lungs, they just can't catch and eject them effectively. So they get past the lung barrier, enter the bloodstream, and then they can travel anywhere, organs, brain tissue. And this triggers chronic, low-level inflammation and cellular damage.
It compounded with every breath.
With every single breath. It's an insidious, slow build-up process.
Right.
And they argue that this constant bombardment eventually pushes a person past what they call their toxic saturation point.
Toxic saturation point.
Yeah. It's the point where the accumulated toxins cause systems to fail, organs to break down prematurely, leading to a shortened lifespan. So the danger isn't the filter material itself causing harm.
It's the false security.
Exactly. It stops people from looking for a real solution while these ultrafine toxins just keep doing their damage silently.
Okay, so if that whole porous filtration idea is fundamentally broken, then this maze air purification system is presented as the necessary next step, aiming for longevity, better thinking, all by getting to zero toxin air, but without, say, gene editing.
Right. Avoiding the risks of unintended consequences from biological modification.
So how does it handle another common approach, negative ions? Because you see cheap purifiers using those, but they often come with ozone warnings.
Yeah, that's a really crucial difference they highlight. Traditional negative ionizers just release free negative ions out into the room air.
Okay.
And the sources stress this is dangerous. Those free ions are like tiny magnets latching onto whatever's floating nearby. This causes what they call uncontrolled particle recombination.
Meaning, instead of cleaning the air, you're actually potentially creating new, maybe bigger, maybe more toxic compounds right there in the air you breathe.
That's exactly the concern. And those newly formed clumps then settle in your lungs. Plus, those traditional ionizers often do produce ozone as a byproduct, and ozone itself damages lung tissue.
Right.
The maze system apparently avoids all that. In step 2 of its process, all the air is forced through a controlled negative ion chamber inside the machine.
Contained.
Contained. So the pollutants get electrostatically charged and neutralized safely inside, in isolation. They also say it breaks apart pathogen aerosol clusters before the air leaves the machine.
Okay, so that controlled charge then sets up the particles for the real core of the technology, this labyrinthine maze system. How does that physical structure guarantee 100% capture, even for those nano-sized contaminants?
This is where the physics really comes into play. Steps 3 and 4 rely on a mechanism called electrostatic impaction.
Electrostatic impaction. Okay, break that down.
So the structure is this multi-layered maze. Think of complex pathways where the air is forced to make multiple really sharp, like 90-degree turns.
Okay, lots of corners.
Lots of corners. Now, impaction is a known physical principle. Those ultrafine particles, the PM0.1s, because they have such incredibly tiny mass and momentum, they just can't follow the airflow when it makes those sharp turns.
They can't corner well.
Exactly. They try to keep going in a straight line. Their inertia carries them forward. But remember, they were negatively charged back in step 2.
Right.
So as they deviate from the curving airflow path, they move straight towards the maze walls, which are designed as positively charged metal collection plates.
So the sharp turn physically separates them from the main airstream.
Yes.
And then the positive charge on the walls acts like a magnet, pulling them in and holding them there permanently.
Precisely. That collision, the impaction guarantees they get permanently absorbed into what they call the electrostatic collection maze box. It's not relying on the random chance of a particle bumping into a fiber and maybe sticking.
It's using physics and electricity.
It uses physics to force the separation and electricity to ensure its lockdown. They claim near-perfect absorption because of this.
Okay, and step 5 is just releasing the resulting ultra-clean air.
Right. And the sources connect this directly to benefits like enhanced mental clarity, less fatigue. The idea being your brain and organs finally get truly purified oxygen, boosting function and long-term health.
But let's zoom out a bit, because the ultimate proof for this method, according to the sources, isn't really from health studies yet, but from heavy industry, specifically semiconductors.
Yeah, this is maybe the most compelling piece of supporting evidence they offer because it links our biological needs directly to the limits of technology.
How so?
The argument is basically this. The level of air purity needed for your cells to function optimally is, maybe surprisingly, mirrored only by the extreme air purity needed to manufacture the world's most advanced computer chips.
And the sources claim HEPA was actually holding back tech advancement.
They do. They explicitly state that relying on traditional HEPA cleanrooms caused huge unstable yields in chip manufacturing. They even allege it trapped major companies, like Intel potentially, at older processes, specifically mentioning the 12-nanometer node.
Why? What was the issue?
Those same ultrafine particles, the PM0.1s that get through HEPA filters, on a microscopic silicon wafer surface, those tiny particles can cause circuit shorts, tiny defects that ruin the entire chip.
So yields plummet.
Exactly. Unstable yields mean you can't reliably scale up production of more advanced chips.
And the breakthrough came from ditching porous filters altogether.
Yes. The sources claim that TSMC, for example, achieved the stability needed for 5-nanometer, 3-nanometer, even 2-nanometer clean rooms only by using an advanced structural airflow system.
And the system is.
They assert it's a technology described in patent documents as the static pressure sealing plus labyrinthine airflow guidance system. They even cite a specific U.S. patent, and they claim this system, which crucially relies on that labyrinthine airflow, not porous filters, is structurally identical to the maze technology.
Wow.
It created the ultra-pure environment needed for those advanced nodes, something HEPA apparently just couldn't deliver reliably.
That's a really critical link they're drawing. The air quality limiting a microchip's function is the same quality limiting, potentially, human brain function.
That's the connection they make.
And that realization, if true, opens this up for huge potential deployment, right? What are the target areas they mentioned?
The scope is massive. On a personal level, they talk about wearable devices. Imagine something for biohackers or people who are immunocompromised, ensuring genuinely 100% pure air wherever they go.
Like a personal clean air bubble.
Kind of. Then for corporate spaces, residential buildings. The goal is creating permanent purity zones, places where you could actually measure improvements in alertness, focus, maybe even workforce productivity.
Makes sense. And beyond commercial uses.
They highlight government and space applications as critical. Military and aerospace uses are mentioned, but there's a heavy focus on long-duration space travel.
Because oxygen purity is absolutely critical there.
Mission critical, especially when you're sealed in a small environment for months or years. They argue this kind of technology is actually necessary to prepare humanity for serious, extended, off-world missions, ensuring the crew stays healthy and cognitively sharp.
So the ultimate promise here isn't just, slightly cleaner air. It's positioned as a fundamental shift. Maybe ending the environmental drag on our species' potential.
That's how it's framed, yeah. The maze system as the key to naturally extending lifespan, unlocking untapped intellectual capacity by creating the world's first, truly zero-toxin human environment. It's presented as a move beyond just fighting disease towards actually maximizing human capability.
Okay, so we've taken a deep dive into some pretty monumental claims today. The idea that high-efficiency particulate air filtration is fundamentally flawed, maybe even harmful in the long run.
Characterized as a pervasive silent killer in these sources.
Right. Then the technical promise of achieving truly zero-toxin air using this maze system's electrostatic impaction.
Yeah.
And finally, that industrial validation connecting this level of air purity directly to making 2-nanometer computer chips.
It's fascinating how the source material really forces you to rethink what pollution even is. It's not just the smog you can see or the dust on your furniture.
The invisible stuff.
It's the nanoscopic contamination that they claim is limiting global tech competition and, at the same time, the biological limits of our own bodies, our own lifespans. It really makes you consider, if optimal brain function truly depends on zero-toxin air, what unseen pollutants might be affecting your energy, your focus, your long-term health right now, without you even realizing it.
That's a heavy thought to end on. This is where our deep dive wraps up, but maybe your own exploration is just beginning. Next time you glance at the filter in your air purifier at home, ask yourself, if it looks pretty clean after 6 months, or even longer, is it really trapping those dangerous PM0.1 toxins effectively? Or has the air just been finding a way around it the whole time, letting those pollutants enter your body unnoticed? Something to think about. We'll see you next time.